Okay. Hello to all my fellow work in progress people. Welcome to Runtime Cognition. So today is Runtime Log 3. In the previous Runtime logs, we have completed backend architecture, um, client server model, and request response cycle, also HTTP methods and REST APIs. So today let's continue with Node.js. Let's see how it goes. Okay. My mentor will be ChatGPT. Let's go. Okay, so quick recap like what I have learned. Mm, yeah, so front end makes a request that is HTTP and to the backend server, and backend server is the decision maker which is responsible for the business logic, and it communicates with the database, and and then at last HTTP response is sent back to the front end and React UI updates. Yeah, so the front end doesn't talk directly to the database. Uh, because it doesn't want to expose the sensitive data to the front end, and it communicates with the backend using HTTP hypertext transfer protocol. It's the common language that both server and client have agreed upon to communicate with, and the backend exposes the APIs. REST gives the standard way to design those APIs. Yes, so I understood that HTTP is like a language and REST is the design principles and guidelines for API consistency. So it is like grammar for the language. Okay, and HTTP methods are get, post, put, patch, and delete. Yeah, so those are mainly to perform the CRUD operations. Okay, you're asking me a question. You built an Express server today. One user opens the website. Tomorrow, let's say 100 users opens it. Next month, okay, okay, 10,000 users opens it simultaneously. How does one JavaScript program handle all these users? Yeah. So JavaScript is set to be single threaded. Yes. So shouldn't the second request have to wait for the first one? Shouldn't everything become slow? If the JavaScript executes one thing at a time, then how does Node.js powers applications like Netflix, PayPal, LinkedIn, and thousands of other APIs around the world? Yeah, how does it do? Now you tell me. This is the central question of today's stream. Yeah. Everything we learn today will answer that one damn question. Okay. So client makes the HTTP request to the backend, and we are figuring out like how does backend gonna run the JavaScript. So Node.js, and then what is JavaScript runtime, V8 engine. So this is the flow for today's runtime log 3. And then single thread, blocking problem, non-blocking solution, event loop, callback queue, microtasks versus macrotasks, and express.js, request lifecycle, and HTTP response. Okay, let's go. So why does Node.js exist? Pause your intro, begin teaching section. Okay. So, okay, before we even define Node.js, let's pretend it is 2008. Unfortunately, it is 2026 now. Okay, the world is running at the rocket speed, but what to do? At this time, JavaScript lived almost entirely inside the browser. Think of a typical website back then, okay? Yeah, it consists of only HTML, CSS, and JavaScript. JavaScript's job was to make web pages interactive. Yeah, so show or hide the menus, validate the forms, handle the button clicks, and basically to add the interactivity to the web page, right? That's it. If the website needed to save a user to the database, authenticate a login, process a payment, or send an email for that matter, JavaScript couldn't do any of that because it only ran inside the browser. Okay. So the developers use backend language like PHP, Java, C Sharp, Ruby, Python, etc. So a web application often look like uh, HTML, CSS, and JS in the browser, and then HTTP request was made to the backend, and backend usually would be either of this PHP, Java, or Python, and then the database layer. So what is the problem? Imagine you're a front-end developer. Yes, I am. That's why I'm learning backend right now. You write a JavaScript all day, but the moment you need a backend, you suddenly have to switch to another language. That means, okay, different syntax, different ecosystem, debugging tools, different hiring requirements, and different mental model. For many teams, this created unnecessary complexity. This is a good place to draw. Okay. Okay, imagine you're fluent in English. You write reports, emails, presentations in English every day. Now your company says whenever you need to talk to the customers, you must switch to Japanese. Even if you are an excellent English speaker, constantly switching languages slows you down, of course, right? Okay, that's exactly what web developers experienced. Front end is JavaScript, back end is another language, and it worked, but it wasn't ideal, of course. It was not the ideal approach. So, the idea behind Node.js, then someone asked a simple but powerful question. What if JavaScript could run outside the browser? Hmm. Not to replace the browsers, not to replace all the backend languages, just to let JavaScript run on the server as well. The idea became Node.js. Okay. So Node.js is a JS runtime that allows JavaScript to run outside the browser, which eventually enabling developers to build the server-side applications using JavaScript. Oh, got it. Notice the wording carefully. Node.js is not a programming language. JavaScript is the language, but Node.js is the environment, meaning the runtime that executes the JavaScript on your computer or the server. The distinction is one of the most common interview questions. Okay, let me copy. So I'm making a notes, which is three-step notes. It's like first revision notes, and then comes the first review notes, and then quick recap notes, and then flash recall, which is for just interview focused or like one-liners. So I'm just documenting my uh, study process itself, like how I'm learning it. I feel like this method is much better. So it's working for me. Let's see how it goes. Instead of memorizing, trying to put some time and effort and understand the concept itself. Okay, I would like to change the color of this so that it would be better for distinction. Sorry, for differentiating between these two things. Okay, imagine you're building an e-commerce application. So front end, say React, it shows the products, shopping cart, and a page to check out. So backend is Node.js. So it receives the login requests, it validates the users, it saves the orders, it processes the payments, it fetches the products from the DB, and it returns the JSON responses. So the same language JavaScript is now used on both client and server. So that doesn't automatically make it the best choice for every project, but it greatly simplified the full stack development and enabled the teams to share knowledge, tooling, and of course, even some code. Yeah. So, yeah. Okay. What is the interview perspective in this? Why was Node.js even created in the first place? Hmm. So originally JavaScript could only run inside the browsers and developers had to use a different language like some backend language, say Java, PHP, Python for the backend development. So Node.js was introduced as a JavaScript runtime that allowed JavaScript to run on the server outside the browser, enabling developers to build scalable server-side applications using the same language on both the front end and back end. Got it. We are explaining the problem first, then the solution. Yeah. for my understanding also, not only for interviewers perspective. Okay, beginner mistakes. Node.js is no, it is not. I know that. Yes, it is a language. Node.js is a framework. No, okay, it is not even a framework. Okay, Express.js is the framework built on top of Node.js. Node.js is replaced, mm, okay, like with the backend languages. No, those languages are still widely used. Node.js is simply added another strong option, especially for input output heavy web applications. Okay, understood. So it's not even a framework, it's not even a language, it's just another way of uh, doing things in, I mean, like writing the backend applications. Okay, now we have answered why Node.js exists, but a new question naturally appears. If JavaScript was designed for browsers, how can it suddenly run on a server? Yeah, before that, hey, don't forget the format. Uh, I know, but like you just gave me the first review, right? Just give me the quick recall and uh, sorry, what is it? I'm forgetting the names itself. Quick recap and flash recall notes as well. I'll just copy paste it in my Notion and then we can continue with the next topic. I don't want to edit this and waste time. Later I can do that. So I'll just copy paste everything over here for now. This things or I will edit later. Okay. Yeah, three-step notes. I want it. One liner summary. It just allows and then the mental model, flowchart. Problem was the context switching. So Node.js was introduced. So JS can now run on the server. So one language for both front end and the back end. The keywords I know. Okay, memory trick. What is it? So JavaScript is the actor and Node.js is the stage that lets the actor perform even outside the browser. Oh, nice analogy. Huh, got it. Okay, let me copy this. Okay, quick, fast recall. What did it give? Okay, why Node.js? That we know. Node.js, what is it? And problem solved. This is important. Why it was even necessary for the Node.js to exist in the first place. Why created? Yeah, got it. Interview answer and the done. I know this topic is like a simple one, but I'm dragging it like crazily and making all of the notes. But it's just that I want to make this practice of understanding the concept, putting the time and effort, and then making the notes so that that habits I can replicate in DSA, system design, etc. Okay, okay, let's continue with this topic now. What is JavaScript runtime? Hey, thanks for giving that notes for the first topic, and we can continue now. Welcome back. Thank you. We have answered our first question. Yeah, why does that even exist? So, more interesting question is what is JavaScript runtime and why? So, let's think about something simple. Suppose when we write JavaScript code like console.log hello runtime cognition. The question is, who actually reads this code? Who understands what console.log means? And who executes that a .js file? Uh, okay, so a .js file is just plain text. Your computer cannot execute the JavaScript directly. It needs something that can understand JavaScript. That something is called a JavaScript runtime. This is the central idea of this topic. Okay, so these console.log. Okay. What is a runtime? A runtime is the environment responsible for loading, interpreting, or compiling and executing the code. Place where the program actually comes to life. Okay. Without a runtime, app.js is just a text file. But with a runtime, app.js with a runtime, it executes the JavaScript. I mean, the text inside that file and it produces the output. Got it. Imagine you have written a beautiful movie script. Does the script become a movie by itself? No. So we need actors, cameras, director, lights, editor, etc. Only then does the movie actually run and comes to life. Yeah. So similarly, JavaScript code is just a script. The runtime is the entire movie production crew that brings it to life. Got it. So browser runtime versus Node.js runtime. Oh, that is also there. Both are different. Browser runtime and Node.js runtime. Okay. This is where many beginners get confused. There isn't just one JavaScript runtime. There are different environments where JavaScript can execute. Okay, now I understood. Runtime is like synonymous with the term environments, right? Environments. So there can be multiple. Okay, so the browser runtime, when JavaScript runs in Chrome browser, JavaScript runtime browser APIs. Okay, the browser provides the things like the document, window, local storage, fetch, DOM APIs. Okay, yeah. So these are not part of JavaScript itself. The browser provides them. Okay. For example, document.get element by ID title. Why does this work? Because the browser runtime gives JavaScript access to the DOM. Okay. Node.js runtime. Now imagine the same JavaScript running on a server. There is no browser. Okay. So there is no document object window or there is no DOM. Instead, Node.js provides different capabilities like file system, HTTP server, path utilities, and operating system APIs, networking, and timers. Okay. So JavaScript const fs file system equals to require fs. Okay, the syntax. So fs dot read file some nodes.txt. Browsers cannot access your computer's file system for security reasons. Node.js can access the files on computer because it's running on the server or your own machine, not inside a browser sandbox. Understood. So the key inside is both environments are different first of all. So a runtime is nothing but an environment, and we can have multiple environments where JavaScript can be ran. So initially it was only browser. Now we have Node.js also. I understood that. And both environments execute the same JavaScript language. What changes is the runtime and the APIs it provides. Okay. So think of it like this word. So there's a JavaScript language and then browser runtime and Node.js runtime. So this gives with objects like window, DOM, document, etc. And this has different set of things like file system, HTTP path, etc. So the language is the same. The environment is different. Both are different runtimes. So this is a good place to draw on whiteboard. Okay, this, yeah, I'll put this total thing in the flow diagram. Okay, great. Production example, okay. So let's say we are building runtime cognition. In the browser, there's React in the front end. So JavaScript updates the UI, it handles the button clicks, say it makes some HTTP requests and displays the interview questions, etc. On the server, it is Node.js. Here also the same language JavaScript, but the JavaScript here has some other jobs to do. Something like it receives the login requests from the UI, it reads from the DB, it saves the user progress, returns the JSON responses, and reads files, sends emails, and a lot. So same language, different runtime, meaning different environments, different responsibilities. Okay. If an interviewer asks what is JavaScript runtime, so JavaScript runtime is environment that executes the JavaScript code. It provides the JavaScript engine along with additional APIs. So browser provides APIs like the DOM window, while Node.js provides server-side APIs such as file system, HTTP, and path modules. Okay, notice we didn't say a runtime is just V8. That's incomplete. We will learn about the V8 next. Okay. All I know is that V8 is the uh, Chrome engine developed by the Google. That's all for now. Okay, common beginner mistakes. JavaScript and Node.js are the same. No, I understood. This is the language. This is the runtime which executes the JavaScript. Document is part of the JavaScript. I really thought it was. Okay. No, browser API, not part of the JavaScript language. Now I have another question. Wait. So file system is part of the JavaScript. No, it's Node.js API provided by the Node.js runtime. So transition to the next topic. Before that, I have few questions. You were saying API. Hey, since you're saying it, these are all browser APIs, right? Like in the browser, we have document or DOM and window, etc. So I thought they're JavaScript objects. Correct me, sorry if I'm wrong. And coming to the Node.js APIs, you mentioned that file system HTTP path, those are modules, right? So you're using the word APIs there. I just want little more clarification on that part. Post that, we can continue to the next topic. Come on here, what's happening? Okay, yeah. So instead of memorizing, I just want to clear the topic and understand. That's why, yeah. So first, let's talk about the document. I thought document is a JavaScript object. Yes, okay, so that's right. Console.log of document. Document is a JavaScript object. So why did I call it a, yeah, why did you mention it as a browser API? So because the browser creates that object and makes it available to your JavaScript code. So think of it like this. So there's JavaScript language, browser runtime, and then it creates window, document, local storage, fetch, navigator. So makes them available as JavaScript objects. Your JavaScript code uses them. Okay, so both statements are true. Document is a JavaScript object. It's part of the browser API because the browser provides it. Okay. The final conclusion is these are not there in the JavaScript by default, but these are given by the browser. Okay, browser gave it to the JavaScript code, the access, got it. So the key distinction here is the ownership. JavaScript itself doesn't define the document. If it did, this code would work everywhere, console.log document. But try running it in node.js. You will get reference error because document is not defined, because node.js doesn't provide the document object. Okay, understood now. So document isn't part of the JavaScript language specification. It's an object provided by the browser runtime. So now about the remaining FS HTTP path, you notice something very important. So these are not Node.js APIs, but you have also learned they are modules. Yeah, that's what I remember. Again, both statements are correct. Let's unpack that maybe similar way. So what is FS file system? Um, is indeed a Node.js core module. Okay. Inside that module, you will find functions like read file, write file, mkdir, and unlink, etc. These functions are the APIs exposed by the FS module. Okay. So think of it like this. Node.js runtime is there, which provides the modules like all these FS, HTTP, which contains all these methods, read file, write file, etc. So FS is the module, is part of the file system API. Understood. You are using the word API interchangeably. That's all, and we can use it both ways. In everyday conversation, developers often say the FS API is shorthand for the API exposed by the FS module. Hmm. So, what exactly is an API here? Application programming interface is simply a way for one piece of software to expose functionality for another piece of software to use. Okay, okay. That said, browser has document so that the JavaScript code can access it. Okay, part of the DOM API. Okay, this is part of the DOM API. FS read file. This is part of the file system API. Okay, both are exposed by this one by Node.js runtime and that one by browser runtime so that the JavaScript code can access and use it. Okay, both are the APIs because they are exposing the functionality that your JS code can call. A better mental model JavaScript code. This is a browser runtime, Node.js runtime. It provides these APIs. It provides these APIs. Local storage fetch window document. Do I have that in the flow diagram or should I again copy paste? Um, I have it already. Okay, I can just include these examples as well. Fetch local storage. A DOM. Sorry, document. Okay. Okay, is document is an object made available by the browser runtime is part of the browser's DOM API, not the JavaScript language itself. That's the biggest insight today I understood. Okay, is FS an API or a module? FS is a Node.js core module. The functions it exposes like these things, all the methods, right? Or from the file system API. Okay. Hmm. Hmm. In practice, developers often refer to the module itself as an FS API, so they can be used interchangeable. Okay, this was fantastic question. Thank you. So JavaScript is a language and environment is the one that provides additional capabilities. Okay. The distinction is going to become an even more important in the next topic when we discuss V8 engine because you are all okay, you will see V8 executes the JavaScript language while Node.js builds on top of V8 by adding server-side APIs like FS, HTTP and path, etc. Okay. Okay. Okay, now thanks for clarifying that question and let's continue with the next topic. So notice how our journey has flowing naturally. Yeah. So front end HTTP understood completely. The back end architecture part understood. Why Node.js I have understood. JavaScript runtime also. Today I got the damn clarity about that browser part and the Node.js. I knew that as a runtime, but the browser part like those document DOM etc. So now what actually executes the JavaScript also? We have learned what a runtime is. Yes, it's an environment to execute the JavaScript code. Now let's open the runtime and see what's inside. Okay. V8 is engine is the next topic and why. So let's go back to a simple JavaScript program. Console log statement is there. Hello runtime cognition. So we write this in English like syntax, but does the CPU understand the JavaScript? It doesn't, right? It only understands the binary language 1, 0, etc. So the real question is who translates our JavaScript into something the CPU can execute? The compiler? This is the problem that the JavaScript engine solves. Okay. So the V8 engine is the Google's high performance JavaScript engine. developed by Google. So its job is to read the JavaScript code, parse and understand it, convert it into optimized machine code, and execute it efficiently. Okay. So without a JavaScript engine, your JavaScript code is just a text. So think of V8 as the translator between the JavaScript and the computer's processor. So this I mean like converts the JavaScript to machine code, right? That's the job of the V8. Okay. So let's separate three things that are often confused. JavaScript is a programming language. V8 engine reads that JavaScript code and executes the JavaScript. I mean by converting it into the machine code. And the Node.js runtime. This provides the server side APIs. Okay. Okay. So notice JavaScript is the language we write. V8 executes that language. Node.js uses V8 and adds the backend capabilities. Okay. So Node.js also uses the V8 and it gives some extra backend capabilities like these things. Okay. Server side capabilities. So this one of the most important diagrams in today's stream. Oh, okay. I'll put then this one. Flow diagram. Okay. Okay, now it's time for some real world analogy. Okay. Reading a book written in Japanese, unfortunately, you only understand English. That's the truth. You need a translator, right? Yeah. So that is the V8 engine. Yeah. JavaScript code, V8 engine, it turns the code to machine code and the CPU executes it. So V8 is the translator. That's a good analogy. V8 is the translator. Instead of human languages, it is translating the code to the computer. Where did V8 come from? Google created V8 for Google Chrome. The goal was simple, make JavaScript extremely fast inside the browser. Later, when Node.js was created, its creator, this guy, thought, why not reuse this incredibly fast JavaScript engine on the server also? So instead of building a new JavaScript engine from scratch, Node.js just embedded the existing V8 engine. So today we have Chrome, which uses the V8 engine, and then Node.js, which is built on the same V8 engine plus some extra backend capabilities, which is that's why JavaScript behaves consistently in both environments, even though the surrounding APIs are different. Okay, so how does this both fit together? Hmm. So your app.js, then the node.js runtime. So V8 engine executes the JavaScript, and node.js have also other extra things like file system API, HTTP paths, timers, etc. Think of node.js as a toolbox. V8 is the translator, this is toolbox. Huh? So inside the toolbox, V8 handles the JavaScript execution here also, but node.js provides all the extra server side tools. Okay. Production example. Imagine login request which reaches your backend. Okay, so client makes the request, okay, post slash login. It reaches the backend. JavaScript code runs. If password is equal to stored password, then the login is successful. So who executes this statement? Again, the V8 engine. Now suppose you want to read a file, fs.read file. Who provides it? It is this API is given by the node.js runtime. So in the same application, V8 executes the JS code and node.js provides the server capabilities for the JavaScript calls. So they work together. So we instead of having another backend setup with Java, PHP, etc., JavaScript does this now because of this. Okay. What is the V8 engine? So it's Google's open source JavaScript. It is open source JavaScript engine. It executes the JavaScript by compiling it into optimized machine code. Node.js uses the V8 engine to run JavaScript outside the browser, while Node.js itself provides additional server-side APIs like this, etc. Okay, yeah. Beginner mistakes. V8 and Node.js. No, I knew that they are different, but today I got much more clarity like what exactly they do. V8 is one component inside Node.js. Yeah, Node.js is built on this. It provides, no, it don't. I know that. Node.js executes. I thought more precisely. Node.js uses the V8 engine to execute. Okay, it's the same V8 engine even in the browser also, in the Node.js also. Yeah. Connecting back to our main question. Um, how can JavaScript handle thousands of requests? Yeah, that was the first thing. Na? We have now learned Node.js lets JavaScript run on the server. V8 executes the JavaScript code. Yeah. So we are still missing the most interesting piece. Even with the V8, JavaScript is still single threaded. Yes. So how does that avoid getting stuck between a lot of requests? Okay. Okay, before that, I have another doubt now. First review. This is too much detailed, but that's okay. I understood completely. I hope I will not open the notes, but yeah, how we came up to that question also is important. I'll put everything here. Later we can edit. Hmm. Hey, can you quickly give the um, quick recap and flash recall notes as well? Then we can continue with the next topic. You're always forgetting the format, yeah. Hmm. You're laughing. Yeah. One line summary, it's a script engine executes the JavaScript by converting it into optimized machine code. Yeah, it works as a translator and then the mental module where V8 fits. Exactly, and then follow chart keywords. This is the important flash recall, like just one liners. So V8 engine, so it works as a translator, converts the code to the machine code. Yeah, same relationship between this and that. JavaScript is a language, V8 executes the language, Node.js uses the V8 plus some server-side capabilities. Okay, Chrome and Node.js shared engine. Yeah, both has the V8 engine, which is developed by Google and open source. Okay, yeah, we finished a lot, right? We came a long way, but with a lot of clarity, which is good. Okay, I'll just put this one there and we can come back here. Notice how my notes are getting shorter and shorter with each and every topic. I mean, this flash recall is like only this much, which is good. Okay. Why does node? This is over. Runtime. Yes. Next comes the turning point of today's stream. If V8 is the one executing the JavaScript code and JavaScript is single threaded, how on earth does the node.js handle thousands of requests? Yeah, but before that, hey, just a small question before that. So you said that V8 is the engine in the Chrome browser, right? So what about the other browsers, like Firefox, etc.? So those browsers are also execute having web pages, right, where the JavaScript is running. So are they also using the V8 engine or some other thing is present in those browsers to execute the JavaScript code there? No, not all browsers use the V8 engine. Okay, each browser has its own JavaScript engine, but they all execute the same JavaScript language, ECMAScript. Okay, ECMA. Think of it, different companies manufacturing the different car engines. The engines are different internally, but they all know how to drive on the same roads because they follow the same traffic rules. So in JavaScript, we have that set of rules by which are ECMA, so the language specification. So we have V8 engine, which is Google's. We have Spider Monkey, JavaScript core. So these are the different engines that implement those rules. Okay. So browser JavaScript engine. So for Chrome it is V8, for Microsoft Edge also it is V8, for Opera V8, Firefox it is SpiderMonkey, for Safari it is JavaScript Core. Okay, JavaScript Core Nitro. Something interesting. Chrome, the modern Edge, and the Opera all use V8. Yeah, so modern browsers are using V8. They are based on the Chromium project. What is that? Firefox chose to build its own engine called SpiderMonkey. Safari uses JavaScript core, which Apple developed. Okay, yeah. In MacBooks, Safari is the default now in iPhones and MacBooks. Mental model. JavaScript has a set of guidelines that is ECMAScript. So Google's V8, SpiderMonkey for Firefox, and Safari has JavaScript core. Different engines are there, but all the modern browsers mostly uses V8 preferably. Okay, the language is same. The engine implementation is different. Real world analogy. Imagine three students receive the same English exam paper. Okay, Alex, Bob, and Charlie. Each student loves the same questions, sorry, solves the same questions, but one writes faster, another uses a different strategy. Yeah, it depends. Another has native handwriting, different approaches, same expected result. Similarly, ECMAScript specification. Uh, V8, Spider Monkey, JavaScript core. So the specification set of guidelines is the same, but these are implementation differences. Okay, each engine implements the same JavaScript specification through the. Okay, then why doesn't my code break? Oh yeah, if Chrome uses V8 and Firefox uses SpiderMonkey, why does this work everywhere? That is what ECMA, they all follow the same, na? I think so. Okay, let x equals to 10 and console log that variable because all engineers implementing the ECMA script specifications. Yeah, see, I got it right this time. That's why we often say we write JavaScript once and different engines execute it. As long as the feature is part of the JavaScript standard and the browser supports the version of the standard, okay, ECMA 6, 7 like that, your code behaves consistently. Then where does that Node.js fit? Now connect this to everything we have learned. It also uses the V8 engine internally and right, so yeah. It does not use SpiderMonkey or JavaScript core. Does every browser use V8? No, different. I understood that. Mother said Chrome was uses V8. That's correct, but here is the more precise statement. Browsers don't execute JavaScript directly. The JavaScript engine inside the browser executes the JavaScript. Yeah, you should have mentioned that. It's okay. So the architecture looks like the Chrome browser rendering the HTML, CSS static pages, and then the browser APIs gives this extra capabilities like DOM, window, object, fetch, etc. V8 JavaScript engine executes the JavaScript. This introduction will become even more valuable in the next topic. Okay, when we discuss single threaded. Okay, how long it's been? 43 minutes. Okay, I'll be just right back in 5 minutes. 5 minutes break, guys. Okay, I'm back. Let's continue. Okay, let's go. Let's continue. What next topic? Okay. Yeah, we have answered why Node.js has to exist in the first place, and what is JavaScript runtime like. There are runtime is nothing but environment, and we have browser runtime and also Node.js runtime, and what is V8 engine. And now we are going to answer this question, which is almost your Node.js. Okay, JavaScript is single threaded. Yes. So how does Node.js handle thousands of requests? Let's build this carefully. Okay. JavaScript is single threaded. Okay. So, but how does this thing handles everything? Okay, first review single thread. Single thread. Okay. I've probably heard people say JavaScript is single threaded, but most people memorize the sentence without understanding what it actually means. So let's get to the topic and understand it perfectly. From first principles perspective, which is good. Okay, what is a thread? Before talking about a single thread, we need to know what a thread is. uh, think of a thread as a path of execution where instructions are executed one after other. Okay, path of execution where instructions are executed one after the other. Okay, your program is just a list of instructions. Yes, so we have statements like console log statements. Some components has to execute them. A thread is the worker that executes these instructions. Okay, what is the meaning of thread? It's nothing but it executes the set of instructions one by one. Okay, real world analogy. Imagine you are working at a billing counter in a supermarket. There's one cashier. Customers arrive in queue, right? Like, yeah, multiple customers. But the cashier cannot serve everyone simultaneously. They serve them one by one, one after one. Yeah. So the cashier is thread. Nice analogy. JavaScript is single threaded, meaning JavaScript has one main thread for executing the JavaScript code. That means only one piece of JavaScript executes at a time. Okay, so execution happens exactly like this. First main thread, it executes the first statement A, then the B, then the C. Okay, it is not going to execute all at once. Okay, so there is only one JavaScript execution thread, which is main thread. Okay, understood. So JavaScript has its one single main thread. It executes the tasks one at a time. Okay, I'll put this as the heading. This should go to our flow diagrams. Make it a at least heading 2, and then I'll put this thing. Okay. So what does one at a time really means? So JavaScript has this code. Say there's a console statement start and then some variable. Okay, we're doing from I to some big number, and we are doing the summation from 0 to this big number, and there is end. So that for loop takes time, of course. While it's running, can JavaScript execute something else? No, because the main thread is busy doing this task, right? So everything else has to wait. This is what people mean single threaded execution. Okay, so then here is the big problem. Let's connect this to the backend. Imagine your Node.js server receives requests from multiple users, say A, B, C, D. If the JavaScript can only execute one task at a time, shouldn't it look like user A finishes and user B starts and user C, and then yeah. So the other users will be in waiting until the one user finishes. That would be a terrible. It will be big trouble. A thousand of users would mean thousands waiting in line, but that's not what happens. Node.js handles thousands of concurrent connections. So, how does that do? Event loop? The important realization is many beginners hear JavaScript is single threaded and conclude Node.js can only handle one request at a time. That's incorrect. Okay. So the distinction between that is JavaScript execution is single threaded. Yes. But Node.js itself is not limited to doing only one thing in the entire system. Okay, that's the key sentence. We are about to discover how Node.js avoids blocking the single JavaScript's main thread. Okay, production example. Imagine you are building a shopping website. Three users clicks the login at the same time. Okay, almost same time. So user A, B, C all click the login button same time. The server needs to read from the database, verify the password, send responses back to the client. So if you JavaScript literally waited for each database query to finish before doing anything else, the server would quickly become slow under load. Yeah. Instead, Node.js has a clever design that lets the JavaScript thread stay productive while waiting for slow operations. Okay. So how does uh, it will stay productive? We are about to learn that mechanism. What does it mean that JavaScript is single threaded? A good answer is JavaScript executes the code on a single main thread, meaning only one piece of JavaScript code runs at a time. So the instructions are executed sequentially. However, in environments like Node.js and the browsers, asynchronous operations are delegated to the runtime, allowing JavaScript to remain responsive because it is only handling one main thread, but all other tasks will be handled by Node or JS or browser's runtime. Asynchronous operations. Okay. Notice I intentionally mentioned the runtime that shows you understand the difference between the language and the environment. Yeah, I do. So common beginner mistake. What? Node.js is a single threaded. More accurate thing is JavaScript execution in Node.js is single threaded. Node.js also uses background threads through libraries like libuv. Yeah, for certain operations, but your JavaScript code itself runs on one main thread. We will dive into libuv later when we cover the event loop. Okay. Yeah, no. Okay, single threaded means Node.js can only handle, but yeah, now only you said na, it is not only single threaded, but it has some background threads also. So it means one JavaScript task execute at a time, not the other server can only have one connected client. Okay. Our main question. So client HTTP request, Node.js runtime, V8 engine, single JavaScript thread, but how does it avoid getting blocked? We have now identified the mystery. If JavaScript can only execute one thing at a time, how can Node.js serve thousands of users without freezing? Okay, leads to directly to our next step, blocking versus non-blocking. But before that, it's notes time. First review. Look how big this has become. Hey, quickly give me notes for quick recap and flash recall. Post that we can continue to the next topic. Huh, yes, boss. This is biscuit here. Every time you're forgetting. JavaScript is single threaded. Yes, but meaning it executes one piece of JavaScript code at a time on a single main thread. Yeah, understood that. JavaScript program flowchart. Real world analogy is one billing counter. There's one cacher is one thread. Thread is nothing similar to cacher analogy. I loved it. Okay, sequential main thread blocking. Yeah, a path of execution that runs instructions. Understood. This one is good. So Node.js is no, I'm not memorizing. So JavaScript execution in the Node.js is still single threaded. Node.js itself can perform many operations concurrently with the help of other, with the help from the runtime. We will see how. Okay, we'll see. Um, I understood maybe that because of the event loop and libuv library, but with 100 100% clarity will understand now. Now it's time for flash recall. So, thread is nothing but execution path, cacher analogy. Path of execution that runs program instructions. Single thread is the main thread. JavaScript executes code on the main thread, meaning only one piece of JavaScript runs at a time. So, sequential execution, yeah, one after another. JavaScript executes a statement sequentially, not in parallel on the main thread. Okay. Common misconception about the Node.js is JavaScript execution is single threaded, but Node can still handle the many concurrent operations using its runtime capabilities. That we'll see. Single thread. Single thread refers to the JavaScript execution, not the server's overall ability to manage multiple clients. This point is important. Huh. Yes, it is single threaded, but this is not about the server's ability to manage the multiple clients. Okay. 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 We'll put this in the flash recall. This is my favorite notes. Only this much. Okay, now runtime cognition. Yeah, we have completed front end. It's a backend. That first one, no, JavaScript runtime V8. Yeah, one main JavaScript thread also main thread over. So yeah, let's continue. Yeah, in today's stream we have completed all this. Now, aha moment. What is that? Blocking versus non-blocking operations. Once this clicks, then the event loop. Okay. Okay, let's go and finish it fast. I'm also excited to study and understand. Okay, why Node.js? Understood JavaScript runtime, understood V8 engine. Yes, single thread. Yes. So now one thread, but why doesn't Node.js freeze and how does it handle everything efficiently is the question. Okay, this is first review notes. So blocking versus non-blocking operations. Let's imagine we are building an login API. So whenever a user clicks on the login button in the UI, the server needs to receive the request, read the user from the database. I mean, like which user had made this request and all, compare the password and send back the response. So, which step is the slowest? Let me think. Maybe database query? Yeah. Okay, not because databases are bad, but because the data might be on another mission or another server, maybe cloud, etc., on another continent stored on the disk. All of these take time, yeah. So now imagine while your server is waiting for the database, should it sit idle and do nothing? No, time waste, no time waste. So should it continue serving the other users? That's exactly the problem Node.js solves. Oh, okay. So what is the logic behind? I mean, like, why should blocking, non-blocking means this one. Whenever there is a time or wait or delay, let the server be busy with some other tasks. Okay. So what is blocking operation? A blocking operation is an operation that keeps JavaScript thread busy, preventing it from executing any other JavaScript code until that operation finishes. Okay, so stop everything and don't move until this task is done. So that is blocking the main thread. Example for that is, okay, there is this code. Yeah, we have already seen like summation. uh, console.log start and then summation happens from 0 to some big number, let's say, and there is an end statement, one for loop. So the execution will be like start very long for loop and then end. While the loop is running, no other JavaScript executes, no callbacks execute, the main thread is busy. Yeah, so this is blocking operation. Okay. Okay. Real world analogy, imagine you are the only cashier at the bank and customer arrives with 500 forms to verify. Okay. So I will finish every single form before calling the next customer. Yeah. Meanwhile, other customers will be they will be like waiting in the queue and scolding the cashier. So everyone is waiting. The cashier is blocked by one customer. So this is like blocking operations. The main thread will be busy, and until that task is completed, it won't move forward. So then what about the non-blocking operations? Okay, smart cashier. A customer one says, I need my loan documents verified. Then the cashier replies like, that verification takes time. I will send it to the verification department. Meanwhile, I will serve the next customer. Please wait. Okay. So the customer one, that thing is forwarded to verification department and then it will be processing. Meanwhile, cashier can go and do his work with other customers. Yeah. So when verification finishes, customer one is called back. Nobody had to wait unnecessarily. Yeah. So that's non-blocking, meaning this process is not blocking the JavaScript main thread itself. So how does this relate to Node.js? So imagine this code, okay, console.log start. So there is this file system, read file method, notes.txt, and then there is this one. Okay, air comma data, there's a callback function here, console.log end. So many beginners expect start, file reads, end, but the output is actually first start and then the console.end, it outputs end, then the file read happens because this part is non-blocking. Because fs.read file is a non-blocking operation, correct? You got it right this time. So here is what happens conceptually. JavaScript starts the executing. It reaches the fs.read file code. Node.js says reading a file might take time, so I'll handle it in the background. Yeah. So the main JavaScript thread immediately continues to the next line of code. Yeah, so it comes here, it executes. It comes here, it says you go to the background. So it continues to this one. That's how the output comes. First start, end, and then at last this one when it is done. Okay. Yeah, what does the important? JavaScript didn't read the file itself. Node.js handled the slow input output operation while the JavaScript thread remained free. Slow input output operation is the file system thing, reading there. Yeah. So this is the first glimpse of how Node.js scales. We will soon learn the event loop, which is responsible for bringing that callback to the JavaScript thread when it's ready. Okay. Now we have sent this function to the background. When event loops comes, we'll see how it's again that output comes to the JavaScript. Okay, it's time to flow diagram. So there is JavaScript single thread, one main thread. It starts console.log. When it reaches file system read file, node.js runtime reads that file in the background. It main thread continues running. So console.log end. Then the file finished. Once it is finished, callback returns and the console.log file is read. Okay, we'll go to the flow diagrams. Before the flow diagram, okay, done. Production example, yes. Let's connect this to a real backend scenario. Suppose three users hit the API almost simultaneously. Okay, so there are ABC users who are hitting uh, products API get to read the products. So each request needs data from the database. If every database query blocked the JavaScript main thread, then until user A finishes, other user has to wait, right? Yeah, they has to wait until he finishes. So your server would become slow and slow. So instead, Node.js delegates the database work, allowing the JavaScript main thread to continue processing other incoming requests while waiting for the results from that background tasks. So when a query completes, its callback or promise continuation is scheduled to run. So this is why Node.js performs so well for input-output heavy applications like APIs, chat servers, streaming services. Oh, okay. So where there is heavy input output operations in that such applications, Node.js is the main choice. Okay. If in What is the difference between blocking and non-blocking operations? Okay, a blocking operation prevents the JavaScript thread from executing the other JavaScript code until it completes. Okay, so main thread. Huh. A non-blocking operation allows the runtime to handle long-running work asynchronously while the JavaScript thread continues executing the other tasks. Once the operation completes, its callback or promise continuation is scheduled to run. The last sentence shows you understand the runtime participates in asynchronous execution and not the JavaScript itself. Okay. Beginner mistakes. Non blocking means the operation finishes instantly. No, it takes some time. The difference is that the JavaScript thread doesn't wait ideally until that time. That's all. So JavaScript is reading the file in the background. Not exactly, but Node.js runtime performs file operations. JavaScript is notified when it's complete. Yeah, I understood that now. Back to our main question. So yeah, we are done with Node. Why the runtime, the V8 engine, single thread, blocking versus non-blocking, and who brings the completed, yeah, that notification, it notifies when it is complete. Who brings that work back to the JavaScript? That's the main question. We have solved half the puzzle. Slow operations don't block the JavaScript thread, but one mystery remains. When the background work finishes, who tells the JavaScript your file is ready, your database query is done? So that traffic controller is the event loop itself. Oh, and once you understand the event loop, you will finally be able to explain how a single JavaScript thread can efficiently support thousands of concurrent requests with confidence. Yeah, first let me finish the notes, the bigger notes. It needs some cleanup, but for now, let it be here. First review notes. Okay. Hey, give me the notes first. That quick recap and flash recall. Post that will continue. I feel like you have Alzheimer's here. Yeah, please fix it. So blocking operations keep the JavaScript thread busy until they finish. Yeah, that's why it's called blocking literally. While the non-blocking operations let the runtime handle the slow work in the background, so the actual JavaScript main thread can continue executing the other tasks. Yes, and the mental model. So there's a JavaScript single thread, blocking operation thread waits, nothing else runs. So there's a waiting period. So non-blocking operation runtime handles the work in the background, so the JS continues executing. So there's no waiting here. Matlab waiting is there, but which is not blocking. The flow chart. Task starts. If the operation is long, JavaScript waits, task finishes, next task starts because it is blocking. So there is JavaScript waiting and blocking also until it finishes. When it comes to non-blocking, the same, the task starts here, but runtime receives the long task and it is processing in the background. JavaScript continues executing the other code. When the background work is completed, that callback or promise ready will happen, and then it will continue. Real world analogy blocking. So, one cashier, customer A 30 minutes, everyone else has to wait. If it is a non blocking, customer A comes, whatever the long task, it is delegated to the other departments for the background processing, and the cashier will continue to the other customers. Yeah, the keywords blocking, non blocking. Threads, waits, runtime handles the slow work in the non blocking. Input output operation is nothing but like the reading files, database queries, and network requests. Okay, so the main thread keeps executing the JavaScript all the time. Background work is handled by the runtime, not by the JavaScript itself. Okay, memory trick. Okay, so blocking means stop and wait. Non blocking means just delegate and continue. Oh, this is nice. So blocking is like stop and wait. Non-blocking will just delegate to other departments or other things and it will continue executing. Don't wait, delegate. Okay. Key insights. Uh, this diagram, do I have it in the flow diagrams? I better put it for one more. Okay. Flash recall. So blocking operation is like wait. Busy thread. A blocking operation keeps the JavaScript thread busy until it completes, preventing other JavaScript code from executing. Yeah. Stop and wait. That's the work of blocking operation. Non-blocking operation is delegate and continue to other work. So this slow work to the runtime it will delegate, allowing the JavaScript main thread to continue with other tasks. Runtime's role, background work. Node.js handles the slow input-output operations like file read, database queries in the runtime, then notifies the JavaScript when they are complete. Input-output operations are like this, and network requests. Reading files, querying database, and making network requests are common input-output operations that are typically handled asynchronously. We'll come to that. Interview point, performance. Non-blocking input-output allows Node.js to efficiently handle many concurrent requests without keeping the JavaScript thread idle. Yeah. Hmm. First, let me put this in my notes. We have completed a lot. Front-end, HTTP, runtime, engine, single thread. This difference between blocking and non-blocking delegates the slow work. Okay, now who brings the completed work back? Yeah. Runtime connection. Uh, Foundations of event loop is done. Okay. Why Node.js? Yeah, run because JavaScript has to run on the server also, not only in the browser. That's the reason we came up with Node.js runtime, the environment that runs the JS and also provides extra capabilities. Yeah, both in browser also in the same thing with the Node.js also different capabilities. So V8 is execution um, engine for JavaScript code, which translates it into machine code. Single thread. It acts like cache analogy. Yeah, JavaScript executes one task at a time. So blocking versus non-blocking. Slow work, which is delegated to the JavaScript, uh, delegated to the runtime so that the JavaScript main thread stays free. Only one question remains. When the delegated work finishes, who brings the call back to the JavaScript thread? And the answer is event loop. Okay, continue. Okay, continue. And also, uh, what about synchronous and asynchronous? Oh, you were waiting for me to ask, huh? Because if I had, they would have become just definitions to memorize. Now you have already understood the single thread, blocking versus non-blocking. So now synchronous versus asynchronous will fit naturally. Okay. I'll slightly change our roadmap. Instead of blocking versus an event loop, I would teach. Okay. Okay. What's the time? How much? It's already 1 hour 17 minutes. Okay. So we are left with event loop, callback, microtasks. Okay, so we have completed till event loop. I want some break. We'll see you in the next um, live stream. So, runtime log 4. In that, we'll continue synchronous versus asynchronous, then the event loop, callback queue, microtasks, and macrotasks, everything in detail. Again, I'm making these notes also. See, because it's very simple and most efficient way, at least for me, is what I felt. And it also creates a habit for me to make the notes. So when there is something, I don't panic in the last minute and it is easy to revise it. The three-step notes. Okay, that's all for the day. Thank you.